Hello. In this video, we're going to be talking about operations on vectors. But before we get into that, let's talk about standard form. When a vector has its initial point on the origin, then that vector is said to be in standard form. And we can use the terminal point to represent it, and that's called component form. Now notice that the component form for a vector has both kind of an x and a y value, but it has pointed brackets around it, so it's denoted as a vector as opposed to a simple ordered pair. In order to find the component form of any vector, you're just going to subtract the x and y values of the terminal point minus the x and y values of the initial point. So as an example, if we have an initial point of 9, -2 and a terminal point of 4, 8, what's the component form for a vector? So what we're going to do is we're going to subtract our x's. So we'll take the terminal minus the initial, so 4 minus 9, and then we'll do the same thing for the y values, 8 minus -2. And so the component form is -5, 10. Now, if we drew this vector, just to get a visual of it, 9, -2, roughly there, 4, 8, something along the lines of that, and we have, there is our vector. And you can see how to get from the initial to the terminal, we'd have to go over -5 and then up 10. And so you could simply count or use a number of other mathematical methods there to figure out what the component form is. And so by saying that our component form is -5, 10, we've basically slid this vector over so that it starts at the origin, then goes over 5, up 10, and creates this vector, which is an equivalent vector because it has the same length and direction. Okay, let's look at some operations. To do multiplication by a scalar, if we have some scalar k, which is representative of a number, and we want to multiply it by vector u, we're just going to take k times both components of vector u. To do addition or subtraction, you match up the first components and you either add or subtract them depending on the sign, and then the same with the second components. Okay, commutative, associative, and identity properties still hold true for vectors. Let's look at some examples. If we want to do 4 times vector u, we're going to take 4 times both components, the -2 and the 7. So we're going to get 4 times -2 and 4 times 7. And then we just evaluate. So the vector becomes -8, 28. And this vector ends up being 4 times longer, both horizontally and vertically. For u plus v, we just add together the individual components that match up. So we'll take u comes first, so -2 plus 3, and then 7 plus -4. And we end up with 1, 3 for our new vector. To visualize this, if I draw the ordered pair, the coordinate plane, and let's do, here's vector u at -2, 7 roughly, so starting at the origin, there's vector u. Vector v, I'm going to put it on the end here from the terminal point of vector u. Then I'm going to go 3 over and 4 down, which lands us roughly there. That's vector v. And so the addition of these two is going to be the same as if I went from the initial of u to then the terminal of v, which is over 1 and up 3, and that's how we get the new vector 1, 3. Okay, we are done.